This program is designed and produced by the community with the support of TV Cogeco.
Good evening, everyone. Thanks very much for the opportunity for Enbridge to be present here this evening and to speak with you about the proposal we have for our Line 9B reversal and Line 9 capacity expansion project. Certainly we understand that this issue has drawn interest in the community of Burlington. We're pleased by that. We're pleased that people are taking an interest in what we're doing. We're happy to be able to come and present for you this evening. I'm going to quickly introduce the folks that I've brought with me. They've all kindly agreed to come. Some of them have come from Alberta. I'll start at this end of the table. Marguerite Folks is Senior Regulatory Counsel with Enbridge. Beside her, Jeanette Gasser is a Major Projects Environmental Specialist assigned to this project.
Just going to turn this on for you, Ken.
Oh, hey. Oh, now I don't even have to try so hard. That's good. Beside Jeanette, we have Les Miscosi, who is with Operations Environmental Specialist. Beside him, Mr. Franz Pruger, who is our Westover Facility Operations Supervisor. Franz would be the local face of Enbridge, if you will. Beside him, we have Mr. Trevor Grams, who's the Director of Infrastructure and Asset Integrity with our company. At the end of the table, Mr. Barry Kallel, who is with our Leak Detection Department out of Alberta. And in the back row, Mr. Eric Prudhomme, who's the Eastern Canadian Public Affairs Manager and my boss. There's Michelle. Sorry, you weren't at the table. You see, you slipped away. Michelle Wislishin is also with us tonight. She's our Government Affairs Manager for Ontario at Enbridge. And is Kent? And Kent made it. Thanks for coming, Kent. Kent Nickel is from the Sarnia office where I work. Kent is our operations engineer assigned to this project. He's been overlooking the actual construction and all the technical details of the work that we're going to be undertaking. So together, hopefully, this group will be able to provide answers to the questions that you may have. We certainly hope so. I'd like to thank Glenn for the introduction and for providing the format for the evening. I'd like to thank Sam in the back corner, who's been our primary contact here at the City of Burlington to help make this meeting possible. And certainly, I'd like to thank Mayor Goldring for being here this evening, as well as the other members of Council. Your Worship, thank you very much for coming out. We appreciate it. What I'm going to do over the next 30, maybe 35 minutes is pretty quickly go through an overview of this project. It will capture some of the issues that have been brought to our attention by this community as well as others. It will provide you with a rationale for what we're doing and why we're doing it. And hopefully in itself may answer some degree or some percentage of the questions that you have. Certainly once that's done, we will make ourselves available to spend the rest of the evening responding to your specific interest. We're happy to do that. So without further ado, I will begin. And the button is that one. A little bit about Enbridge, for those of you who may only think of Enbridge and think of Enbridge Gas. Enbridge is a multifaceted energy transportation company. We're located, our head office is in Calgary, Alberta. We currently have about 10,000 employees working with the company. We have interest in a lot of pipeline in North America, both in the U.S. and in Canada. Over 15,000 miles of pipeline, to be exact, in Canada. We have been recognized as one of the world's most sustainable companies by Corporate Knights. We've had that distinction for several years in a row. We're very proud of it. It's a difficult thing to achieve. We are also committed, and I think this is the most important part of this evening tonight. We are committed to being a responsible corporation in all the communities where we operate. We are committed to the safety of our employees, to the safety of the public, and to protection of the environment. These are critical issues for Enbridge. They are job number one at Enbridge. Secondly, we are committed to building relationships with the stakeholders who are interested in what we do. So we deal with many levels of government, federal, provincial, municipal. We deal with landowner associations. We deal with individual landowners because our pipeline crosses many privately owned properties. So these relationships are very important. And finally, we believe in transparency. We believe in sharing information. So again, to use this evening as an example, we're very happy to share information about the work that we're proposing to undertake here in Ontario. This map, I hope it's not too hard for you to see the colors in it from where you're at. This map shows you our pipeline assets in the province of Ontario. You'll see down in the corner there on the left is Sarnia, and we have several lines which extend eastward from Sarnia to Westover, which is just in Flamborough, outside of Hamilton. And then from there we have one blue line which goes all the way to Montreal. The blue line, which you can see if you see it's in that part of the section between Sarnia and Westover, and then the part of it going to Montreal is line 9. Okay? So this is the project, this is the pipeline that we're talking about. What we're talking about doing is reversing the flow of this pipeline. So first thing to understand is the pipeline's already there. It's not going to be a new pipeline, it's been in the ground for quite some time. Oops, one too many. Got to go back. Can't see. Scroll down and can't see. This doesn't seem to be moving for me.
We'll get the mayor working the line.
Just go back for me if you wouldn't mind, Your Worship. Thank you very much. I think just one more. Oh.
Too far?
I did it again. You put it back and I hit the button and it went forward again. So I need to go back. I'll try that on the table. It's not working up there. There we go. So this perhaps gives you a little bit a better image of line 9. And you can see that it extends again from Sarnia to Montreal. And you can see some of the localities, some of the communities through which the pipeline runs. One of the things I will note is that this pipeline, in fact, does run through the City of Toronto and has been in the hydro corridor there for quite some time now. So, thank you. I put this slide in simply to show you where the pipeline is in proximity to Burlington. Our pipe is located at towards the northern side of the city. Again, you can see that it's running through Mississauga on its way to Toronto and then on its eastward journey after that. So really just to provide us with a sense of where we're standing and where our pipe asset is. So a little bit of background about Line 9. I've mentioned it's been around for a while. It's a 30-inch diameter pipeline. It's 831 kilometers long from Sarnia to Montreal. It has an approximate capacity of 240,000 barrels per day. It was originally built, entered into service in 1976. It was actually constructed between 1974 and the end of 1975. It was built in a west to east flow. So when the line was first put into service, it actually ran from west to east, which is the directional switch now we're saying to reverse back to. So that the comment, a re-reversal, would apply to the pipeline. It was built at the request of the federal government, who was dealing with energy scarcity, some concerns about foreign oil supplies during the decade of the 1970s, the oil embargo, if you will. In around the mid to middle 1990s, offshore oil production became very affordable because there were many countries in the world who began to export large quantities of oil. Refineries who were located in eastern Canada, because of their proximity to salt water, realized that they could save money if they were to start buying foreign-sourced oil. So in the 1990s, Enbridge applied to the National Energy Board to reverse the pipeline so that it started to flow from Montreal towards Sarnia. Okay? This was basically done because of economic drivers on the market. What we're suggesting we're doing now with the re-reversal is for the very same reason. This is being driven by economic drivers, being driven by a request, if you will, from our customers. In July of 2012, the National Energy Board provided Enbridge with a permit to reverse the section of Line 9 between Sarnia and Westover. This request was put forward because of a request we had received from Imperial Oil, who operates the Nanticoke facility, seeking greater access to Western Canadian crude. Now, I didn't give you the price, and this is probably the best, easiest way to put this. Offshore crude currently costs about $25 to $30 more per barrel than Western Canadian crude. If you take an example like the Suncor refinery that operates in Montreal East, it represents, if they had access to Western crude, it represents a savings for them of about $1.2 million per day. So it's fairly substantial. And these are really the economic forces in the market that are bringing Enbridge to this proposal. This is why we're doing this. I can also mention that the NEB granted us the permit for Line 9A. In May of 2012, we filed an application, or we filed a notification to the National Energy Board that we would be seeking a permit to reverse the remainder of Line 9B, Westover to Montreal. Why? Because in the process of getting our permit for Line 9A, our customers further east of Nanacoke, predominantly in Quebec, asked us to, because of the same reason. They have the sense that they could save themselves a fair bit of money. The benefits I've mentioned, in principle, I've mentioned maybe the biggest one, but there are a few others. This project supports the concept of Canadian oil for Canadian refiners, Canadian oil for Canadian consumers. These facilities would be able to source crude from Western Canada, where, as you know, there's an abundance of crude, and all types of crude. It's a more secure supply. It's got a price advantage right now. And it's probably, in some ways, as it's been put by some groups, a more ethical supply. There are some people who say that offshore crude from certain sources in the world is questionable. And I'll leave that with you. Draw your own conclusions on that. But it is one of the benefits that our government certainly sees of having a domestic, secure energy program here in Canada. So this process would help to secure the economic viability of refineries that are located in Eastern Canada. It would help them be more competitive, because right now they are paying that premium, whereas some of their competitors who are located in other parts of North America who already have access to Western crude have a bit of an advantage in the market. It would protect their viability, and by that really it comes down to protecting the thousands of jobs that work, or the people that work in the energy sector in Eastern Canada. And then the other, probably in the case of Montreal, to use that example again, maybe 2,000, 3,000 people who work in support of the refinery in Montreal East. You may know, you may not, there used to be 7 petroleum plants in Montreal East. There's only 1 now. The other 6 have closed. And they've closed for a lot of reasons, but certainly the economics have been a big part of that. A lot of people have lost their jobs. And as you can imagine, petrochemical jobs, engineering-type jobs, high-paying jobs have been lost. So the mayor of Montreal East and his community are very concerned about the 1 remaining refinery that they have there. The scope of the project. What is it that we're going to do? We are going to increase the flow of this pipeline, which currently sits at 240,000 barrels, to 300,000 barrels per day. All of the work that we need to do, because this is an existing pipeline, it's a pretty straightforward project for Enbridge from an engineering point of view. This is not a complicated process for us to undertake. All of the work required will take place within our existing facilities. So by that I mean the terminal we have in Sarnia, the terminal facility we have in Westover, the terminal facility we have in Montreal. We also have a series of pump stations along the pipeline which pushes the oil. There will be work that will be undertaken at those facilities too. But we don't need to purchase or acquire any new property. We don't need to expand our footprint in order for this project to be undertaken. We will be shipping primarily light crude. And this perhaps is something you haven't seen so much in the newspaper. But our customers have requested us to send them light crude, not oil sands-based diluted bitumen, at least not in quantity. They are currently equipped in Eastern Canada to handle light crude. That's what the refineries were designed for. So they've asked us to send them light crude, except this light crude comes from Western Canada as opposed to offshore places such as North Africa and the North Sea and South America and the Middle East. This is nothing new to Enbridge. We ship a wide variety of crude slates on our pipelines, and we've been doing it across the continent for 60 years. So shipping light, shipping heavy, shipping diluted bitumen is not new. It's something that we have a lot of experience doing. How will we get from 240 to 300,000 barrels a day? we will introduce a polymer agent which is referred to as a drag-reducing compound, or DRA, drag-reducing agent. It's basically liquid polymer. What it does is we inject it into the pipeline, it coats the inside wall of the pipeline and reduces the friction of the oil as it travels down the pipe. It's hard to imagine that oil, which is slippery by nature, would actually have friction, but it does. And by the introduction of this material, we can actually increase the volume that we can put through the line in a day by 40,000 barrels without having to increase the diameter of the pipe or by having to increase any pressure operating on the pipeline. Pipeline integrity, security, keeping the product in the pipe. It's important. It's important probably to Enbridge more than anyone else. Over the last decade, we've transported about 12 billion barrels of oil, and we've done that safely. Our performance rate is better than 99.999%. That's pretty good, but it's not perfect. Enbridge strives to eliminate every spill. No spill is acceptable to Enbridge, and we take that commitment very seriously. We had a spill in Marshall, Michigan in 2010, and it was a serious spill by anybody's definition. We took it very, very heart to heart, and we responded to the best of our ability. We have done a lot since the Marshall incident to ensure that we never have to deal with something like that again. And our team tonight can provide you with many examples of those improvements because they've happened across the board at our company. We've started with a new emphasis on safety culture, which applies to every employee, new, old, doesn't matter. We've introduced 6 life-saving rules, which are things that Enbridge employees must do. Failure to comply with the 6 life-saving rules means you no longer work for Enbridge. The commitment that the senior executive committee have made to improving our safety performance has really kind of impressed me. Because one of the things, as you'll see in some of my slides, is they have poured resources into these issues. One of the things of note, again, to address something that's been widely publicized, is the fact that if we were to transport heavier crude oil or diluted bitumen, that material would pose a greater risk to the pipeline because of corrosiveness. Simply put, this isn't true. The Marshall incident was not caused by internal corrosion on our pipeline. It was not caused because of the product that was being transported in the pipeline. And that was borne out by the investigators' report, the National Transport Safety Board in the United States. And I've cited the page number in their report if you want to see it. It's all available on the web. I mentioned resources, and here's where we can start to see some of that. In 2011, and again in 2012, we've invested $450 million to improve our integrity management program across the network. We've conducted 3,000 pipeline investigations and excavations during the same 2-year period, and we've run 175 inline inspection tool runs on our pipelines. These are expensive, complicated undertakings, but they are critical to allowing Enbridge to have the information we need to ensure the integrity, the operating condition of our pipeline. Our company has committed $800 million to the same program in 2013. All of our pipelines are monitored 24 hours a day, year-round, from our control room, which is located in Edmonton. We use sophisticated control systems, including automatic leak detection, shut-off valves, alarm systems. We keep a close eye from our central headquarters, if you will, on all of our pipeline assets. We use cathodic protection to protect the outside of our pipeline from corrosion. All of our pipelines are monitored using the internal inspection tools, which I've mentioned. Those tools look for specific anomalies, or defects, if you will, in the pipeline. They look for corrosion. They look for cracks, dents, geometry issues where the pipe might not be round because of pressure that's been applied to it. The tool data that we collect from the tool runs forms the basis for our integrity management investigative dig program. We find something on our pipeline. The next step is to go to that location, excavate the pipeline, and visually inspect it to see what we're dealing with and determine what kind of repair is required. In the past 12 months, Trevor, 12 months, we've run all of our tools on Line 9 between Westover and Montreal to get up-to-date information on the condition of the pipeline. We are now in the process of analyzing that data, and please understand there's a lot of data to analyze because these tools look at the pipeline millimeter by millimeter around the entire internal circumference of the wall. So millimeter by millimeter for 832 kilometers. That's the level at which we're looking. This analysis will tell us where we need to go, physically excavate, dig up the line, and conduct repairs, or at least visually check to see if the pipeline tool is accurate. It's found something at the right milepost on our pipe. We go to confirm the tool data, and then we take action to repair, replace section of the pipeline as required. So these projects are excavation. You'll see heavy equipment on the pipeline route, crews out working, people with shovels, because as you get close to the pipeline, our standards say you have to do your final excavation by hand to ensure you don't hit the pipeline. All of this work that needs to be done will happen on Line 9B before the reversal goes into service. So before 2014, we're thinking maybe the beginning of the second quarter, all of the work we need to do will be completed. We will also be taking measures to share this information with the communities that are impacted by it. As I've mentioned, we identify where we need to do a dig. So what we're going to do is we're going to communicate that information to the municipality, to the planning department with the city, to the conservation authority responsible for that property ahead of time, so they know what we're doing as well. They can see where we'll be, hopefully when we'll be there, and we can try to accommodate other people who have interests in those pieces of property. Certainly when you're dealing with private landowners and you're asking them to allow you to come onto their property to undertake this kind of work, it's very important that you accommodate their interests. Many of them are agriculturalists, as you can imagine. Leak detection. Not the same thing as integrity. And that's something that I've seen reference to, which seemed to me to indicate there was some misunderstanding on that. Enbridge detects leaks using 4 primary technologies and methods. Each of them has a different focus. Some of these phrases I'm going to read off to you now, I'm going to be honest with you. I'm in public relations. I'm not an engineer. I'm not quite sure what some of these things mean. But we got people here tonight who run this, and they will explain it to you so that you understand it and so that I understand it too. But I got the opportunity to deliver the overview, so I'm going to run through some of these things. We use controller monitoring, which is a pipeline operator and SCADA system. We use computational pipeline monitoring, or CPM. We use visual surveillance and third-party reporting, and we also schedule line balance calculations. Now, to me, I'm not quite sure what those terms mean, but I know that they're all intended to determining if, where, and how we might have a leak on our system. Enbridge is always looking for ways to improve our leak detection system. We've made enhancements to the procedures, to our training programs, to the performance of our CPM, to the management of critical detection equipment. We are assessing commercially available leak technology, new leak detection technologies, to make further improvements to our system. And we're waiting for some results on some fairly exciting new tools that are being developed later this year. On Line 9A, between Sarnia and Westover, we've spent $8.5 million on leak detection instrumentation, improvements, new flow meters, pressure and temperature transmitters. On Line 9B, there's ongoing detailed design as part of the reversal project that's underway. We plan to spend another $5 to $10 million on leak detection equipment on Line 9B. The environment. It's critical, and we know that, and we have a responsibility to protect it. And obviously, as you can imagine, the people in Marshall, Michigan in 2010 made that point very clear to us, and we felt for the impact that we had on those people. We took it hard. It was a blow for Enbridge, and we've tried very hard to improve where we found opportunities to do that. Enbridge takes that responsibility for the environment very seriously, and we have numerous programs, comprehensive overlapping programs, to ensure that the way we do our business maintains respect and protection for the environments and the ecosystems that we travel through. And we travel across all kinds of topography. We go under rivers, we go through wetlands, we go over hills, we go through farm fields. Lots of different kinds of environments, important environments. As part of our application to the National Energy Board, we submitted an environmental and socioeconomic impact assessment. This assessment looked at the work that we needed to perform to reverse the line and monitored and assessed what the environmental impacts could be associated with that work. We've identified that because the work is very limited and it will occur on existing right-of-way and at our facilities, the impact that we perceive to the environment from this reversal is minimal. Environmental plans, policies, procedures, and training of staff, all of the contractors that do our integrity work for us, all of these things are mandated and regulated, monitored and approved by the National Energy Board as well as internally within Enbridge. We are trying to apply the best industry standards possible to our environmental performance. So, if we have an incident, is Enbridge ready for that? And the answer is yes, we are. If we have an event, if we have an incident, if we have a spill, Enbridge will react quickly and efficiently. We will address the incident through a comprehensive environmental monitoring program that's appropriate for the site-specific conditions that we encounter. And it's important to understand that because of the nature of our business, because we travel across property, kilometer after kilometer, that environment changes. So the response and what we can do and how we can do it changes. The program is also in line with the NEB's remedial process guide, which is their expectation as the regulator of our business on how we would conduct an investigation and an incident response. Contaminants of concern would be identified. They would be monitored in all relevant environmental receptors: surface water, groundwater, soil, sediment, air, living organisms. All would be studied, all would be taken into account, and everything would be done to protect all of them. The analytical results of this investigation, if we had an incident, would be shared with the community, with stakeholders impacted, and with government. Again, another dollar sign. $50 million has been spent in 2012 and 2013 on improving our spill response capability, purchasing equipment, training, just overall making tweaks to make our system better so that we're ready to deal with an incident. We're looking at specific programs to build better tools and techniques for worst-case waterborne spills. Again, to use Marshall as an example, the Kalamazoo River in Michigan was impacted by our spill. We were challenged with new conditions we hadn't encountered regularly before. There were technical things we needed to surmount, and we did. And now we're applying those technologies and those learnings to our entire system. In 2011, we created a cross-region unit response team for large-scale events, for things that are too big for one region to handle on its own. Something else we learned from Marshall, a remote location in Michigan. There wasn't enough equipment. There weren't enough people. We couldn't get the resources there fast enough. That was something we learned we had to improve on. In 2011, we also created a dedicated emergency response group in Operations Services for increased regional support. And what that basically means is we now have employees who are dedicated to emergency response at all times. These are people who specialize. They take extensive training in emergency response procedures. They have been located and they're on staff across our system, ready to respond. We're also involved with a third-party assessment of our system because we know we don't see it all best from our own point of view. We've asked a firm to come in and do an assessment of our preparedness. How are we doing? Where can we make improvements? Let's bring it all to home. Let's bring it back to the Eastern region because I'm talking kind of in policy and corporate level stuff. Here in Eastern Ontario, our plan determines predefined control points on water crossings that our pipeline crosses. We know where to go. We know where to deploy boom. We know how long it would take for the flow in of the river to carry the oil from the pipeline to a larger river or to Lake Ontario, to use that example. All navigable water crossings, all rivers, feature isolation valves on either shoreline. We can isolate valves on our system within 3 minutes from our control room in Edmonton. So we can shut down our line. We can try to contain the amount of oil in sections of our pipeline to minimize the impact of a spill incident. The pipe wall between river crossings is a ½ inch thick. Typical pipe wall is about a ¼ inch thick, but when we go under a roadway or under a river, under a wetland, high circumstance environments, we increase that pipe wall thickness for added protection. We've created new contractual arrangements with spill response contractors. These are external contractors that do specifically this for a living. The two largest in Ontario are the Eastern Canada Response Corps and the Response Group. We also have contracts with multiple small contractors along the pipeline route, backhoe operators, heavy equipment operators, people we've identified ahead of time to bring into a response should we need them. Again, something we learned from Marshall. You can't have too much help. We exercise with these groups regularly, so they're familiar with what we do, they're familiar with our assets, they're familiar with our products, they're familiar with the operating pressures, etc., etc. They know our business. We also meet annually with fire and police emergency responders in the communities along the pipeline. We've had meetings with the fire chief here in Burlington. I'm pleased that he was able to come out, and deputy chief as well. We've met with them before, we've trained them, they know where our asset is through the City of Burlington. We've done that with all of the communities along Line 9. Some information about the oil sands, because again, media reports on this project have focused on this. We've been transporting crude from the oil sands for 40 plus years. We feel that we're experts on transporting oil of any kind. And to be honest, we don't see much difference between oil sands-based crude product and other types of heavy crude that are sourced from other parts of Western Canada and other parts of the world. The Alberta Energy Resources Conservation Board released a press release in February in 2011 saying that pipelines are a safe way to transport oil sands-based crude. We agree. There's been 2 studies conducted by Natural Resources Canada last year indicating that the increase or the statement that there's an increased risk of corrosion associated with diluted bitumen or oil sands-based crude is higher. These studies indicate that is not the case. Corrosive materials are removed from before the oil is introduced into our pipeline. If I can put it this way, we have standards that the oil has to meet before we'll put it into our pipe. It can only have 0.5% of water in it. It can only have a certain amount of suspended solid in it. The viscosity has to be at a certain level. If it doesn't meet those criteria, it has to be upgraded so that it does before it can be put into our transmission lines. Enbridge is not going to put anything into our asset that could potentially damage our asset. It just doesn't make sense. It's also interesting to note that conventional and diluted bitumen oils both inhibit corrosion. You put oil in your car kind of for the same reason. Oil inhibits corrosion. What causes corrosion in a pipeline isn't the type of product, it's the water that's in the pipeline. That's the cause of corrosion in a pipeline, and that's one of the things that our integrity program is designed to detect. Finally, refineries in Canada and the US have been using Canadian heavy crude for a long time. It's a source of energy that we rely on as consumers. We run our vehicles with it. It creates many of the products that we use, and that's not something that's just happened. It's been around, it's been available, it's been used for many years. So corrosion. I've indicated that the claims that oil sands derived crude or diluted bitumen or dilbit cause higher levels in corrosion in liquids are not true. And there are several studies that point that way. The corrosivity of crude oil, including dilbit, is extremely low. As I've mentioned, pipeline corrosion is related to water. Typically, water in gathering system pipelines, in the oil sands themselves out west, where you have as much as 50% water in the pipeline. There have been an indication that in those situations there is a higher risk of spills, but it's not because of the dilbit, it's because of the water. Transmission pipelines require that sediment water levels in the oil are very low. I've mentioned that. We've never experienced an internal corrosion failure on any of our mainline system. And again, I would attribute that to the fact that we have criteria and tariffs that must be met for the oil to be introduced into the pipe. What do we do to control corrosion? Well, a few things. We test all the crude before it goes into the pipe. We use cleaning pigs, which are internal cleaning tools, to clean the impurities such as sediments that might gather on the bottom of the pipeline, to take out wax that might collect on the wall of the pipeline. Wherever there's an internal corrosion risk, we run these tools. We add corrosion inhibitors to nullify the corrosive effects of water. We use cathodic protection on the outside of the pipe to protect it from natural occurring corrosion. And we're still looking for better ways to do things, and that'll never change. We're always looking for better ways, improvements that we can make on our system to make it safer. Again, a little more information I'll share with you on Marshall, because Marshall has been cited many times in recent newspaper coverage of our project. The event occurred in July 28th, I believe, in 2010. 2 years later, in 2012, the authorities in Kalamazoo reopened the Kalamazoo River. They reopened it for recreational use. We were very proud that day. Enbridge continues to be on the ground in Marshall. We're still working there. There's still more to be done, more restoration work, monitoring work that will be ongoing for several years. We expect to make payments for additional costs associated with submerged oil and sheen monitoring, recovery operations, containment management, groundwater monitoring, lots of things still going on in that area, as well as legal and professional costs through the next few years for sure. The point I'd like to make here is what happened in Marshall was unfortunate. It was serious. But Enbridge was there, and Enbridge took responsibility for it. And we're still there, and we're still taking responsibility for it. And if you were to talk to the mayor of Marshall, I think the mayor of Marshall will tell you that it's a very unfortunate incident. I wish it had never happened. But it did happen, and I'm glad the company involved was Enbridge, because they've been very responsible and they've treated our community very well. It's cost us over $800 million. So it's not small change. It's not something we want to have happen again. Our control center in Edmonton, lots of changes have been made there. Lots of things have been interpreted, learnings from Marshall, improvements to our system. We've changed the way we handle pipeline startups and shutdowns. We've improved and changed the way our leak detection systems work in the control room. We've enhanced our communication protocols, and we've created new systems, if you will, new procedures to deal with suspected column separations, which is what was involved in the Marshall incident as well. We've enhanced the organizational structure for better support of our operators to manage the span of control and the workload. I'm not quite sure what kind of work you all do, but a control room, 24 hours, 7 days a week, sometimes it's monotonous. There are challenges to working in that environment. Enbridge is looking at new ways to make that work environment more pleasant for our employees, because that's important. It also impacts their performance. We've augmented our staff, we've added more training, more engineering, and we've just increased the number of people. Prior to the Marshall incident, we'd already started a project to actually build a new control center, which has now been completed and is open. It's in Edmonton. And it's a new approach to this 24-hour around-the-clock working environment, designed to be more ergonomic, more comfortable for the people working there.
Ken, respectfully, I know you have a few more slides. If I could ask you to get through them in about 5 minutes or so, because I want to maximize the time available for the group to ask questions. Thank you.
I got 5 left, folks.
Great.
I hope nobody's falling asleep. And I can go through this quickly. Stakeholder consultation on this project. We've met with the government at all levels in the province of Ontario and the province of Quebec. We're meeting with MPPs, elected officials at the municipal level across the pipeline route. We've had engagement and dialogue with 14 First Nations. We've sent notification and description letters on the project to 2,645 landowners and 110 municipalities. We conducted 5 public open houses in Ontario and 2 of them in Quebec to date. We've also created a project-specific website and an email service for any stakeholder or any citizen to ask us questions. There's lots of information on that website. I encourage you to look at it if you haven't already. This project is overseen and regulated by the National Energy Board. I've mentioned the NEB a few times. We are an interprovincial pipeline. We cross pipeline or borders for provinces as well as countries. That makes this a federally regulated project. National Energy Board is that regulator. When we applied for this project, we had to submit 3 basic documents. The first one was an environmental and a socioeconomic assessment, which looked at the environmental impact and the socioeconomic impact of the project. The second was an engineering assessment, which looked at the condition of the pipeline. Very important part of our application. And the third is we had to show evidence and procedures on how we were going to meet all of the operations and construction standards that the NEB has. So those 3 pieces form the basis of the application. Move my slide. Sorry, thank you. Subject to attaining a permit from the NEB, at that point, Enbridge would then enter into a dialogue with all of the other agencies that have a right and a permitting process on this project. So the province, the municipalities, the conservation authorities, all would be involved. For those of you who are taking notes, you might want to write this down. If you're interested in learning more about the NEB process, these are the web resources that are available. And certainly we can talk more about the NEB process and how to get into that. Part of the reason Margaret's here tonight is that's her area of specialty. In summary then, this project will protect the viability of Ontario and Quebec refiners and open a new market for Western Canadian producers. Pipeline integrity, the safety of the public, the safety of the environment are our #1 priorities, and they always will be. All the work we need to do will happen on our facilities within existing easements. No new property is required, except for a small piece of temporary laydown workspace near Westover. We've already talked to the landowner, and he's happy to have us use his property for a couple of months. We filed our project application with the board on November 29th. On December 19th, the NEB determined that the application was complete and set the project for a hearing, an oral hearing in this particular case. The last piece here is the process advisor for the project. His name is Michael Benson. I've included his phone number and his email address here for those who would like to speak directly with him, as well as the NEB's toll-free number to get more information from them if you'd like to. That's the information online that we have for you to use if you're looking for information on our project. And basically, on that, I will end the formal presentation.